Now I want to discuss the issue of bonding. How do these atoms bond together? Well, there's three types of bonds. You've got ionic bonds, you've got covalent bonds, and you've got metallic bonds. Ionic bonds occur between a non-metal and a metal. Non-metal and a metal. And this is when electrons are transferred from the metal to the non-metal. Now, what happens this creates positive and negative ions, yeah? Because they've not got balance with the protons and electrons, they will classify as positive and negative ions. And these are attracted to each other by electrostatic forces. So they're still bonded together. The metal donates the electron from its outer shell to the non-metal. And this leaves both atoms with a full outer electron shell and the charge. That's the problem. So they've got a full outer shell, but they've got a charge because they're ions. And these opposite charges cause the ions to be attracted to each other. For example, sodium and chlorine, yeah, make sodium chloride. Yeah, sodium and chloride. Oh, now, as you can tell, these atoms combine at an equal ratio. Can you see that? Sodium plus chloride, Na plus Cl gives NaCl. Now, as you can tell, these atoms combine at an equal ratio, 1 to 1. Why is this? Well, look at the atom. Sodium has an atomic number of 11 and chlorine has an atomic number of 17. If you look at them in the table there, 11 and 17, both of them, look at the structure. One has got 1 electron in the outer shell and one has got 7. In other words, it's got 1 missing. That's why they're combined. As you can see there, one's got 1 extra and one's got 1 missing. That's why they combine at a ratio of 1 to 1. It needs 1 more electron to fill its outer shell. That is why they give the sodium, gives it to this electron, gives it out to fill it up. That's what happens. That's why sodium chloride combine like that. This bonding, however, creates 2 ions because the sodium has 10 electrons orbiting but it's got 11 protons, giving it a net positive charge. The chlorine atom has 18 electrons orbiting it with only 17 protons in the nucleus, giving it a net negative charge. As you can see there, the ions. Because of this charge, they do combine together to form sodium chloride. Sodium chloride. Now, what are the properties of molecules with ionic bonds? Well, first of all, they are generally solids at room temperature. They are giant structures. They have got high melting point temperature, high melting points. They conduct electricity when molten or dissolved in water, and they can be brittle and they can shatter. So that is the ionic bonds, metals and non-metals, where metals give electrons to non-metals to create ions, and then they bond together due to electrostatic forces, but they've still got full outer shells. They're not sharing them. They're not sharing them. The next type of bond I want to talk about is covalent bonding, and this occurs between 2 non-metals. So covalent bonds is non-metals, and it's where electrons are shared between the non-metals. An electron is given from both of the atoms, so they basically share them. Now, you can get double covalent bonds where they basically share 2 electrons, where 4 electrons are shared between 2. So one will give 2 to the other, and they share them. So 4 electrons are shared between the non-metals. 2 are given from each. A good example of this is chlorine. Chlorine and chlorine make chloride. So Cl plus Cl makes Cl2. Now, as you can see here, what this is saying is chlorine has got an outer shell with 1 missing. Both of them, 1 shell missing. What they do is they share an electron each. So the chlorine gives it an electron, and the other chlorine, so they both share and combine. Can you see there? Chloride. That's chloride because they've both got full outer shells because they're sharing an electron. They're sharing those 2 electrons between them to make full shells. What are the properties of covalent bonds? Well, molecules that have got covalent bonds have low melting point temperatures, and that's why they're generally gases. And that's why they're generally gases or liquids, because they have got actually low melting points. And a good example of this is methane, oxygen, water. These have got covalent bonds. Now, the strong covalent bonds are only between the atoms in the molecule, and these are not easily broken. Now, the weak intermolecular forces, which is the attraction between the molecules, are there, but the bonds, these can be broken, the intermolecular forces, but the forces inside the atoms together are quite strong. They can be broken. They've also got weak attraction between molecules, and they're generally poor conductors. So gases are generally poor conductors. Now, the last one I want to talk about is coordinate bond. And this is where one atom provides both electrons in the covalent bond. Now, atoms that accept it is basically electron deficient. Atoms that donate has a lone pair of electrons. This is a good example of a coordinate bond here, when NH3 ammonia combines with hydrogen to make NH4. Can you see there? NH3 plus hydrogen ion make NH4. That's a good example there.